In this video, I'm going to be going over 2.6 part 3, which I gave you two rational functions and asked you to follow these 7 steps here from our notes to graphing rational functions. I'm going to go through both of these examples and do them completely out, explaining each step following this 7-step process. Right. So this first one, our first step is always simplifying the numerator and denominator by factoring, right, and also canceling out whatever we can cancel out. The top here factors to x minus 2, x plus 1, and the bottom factors to x plus 3, x minus 2. So we can see here that the x minus 2 is going to cancel out on the top and the bottom, which gives us this fully simplified form, x plus 1 over x plus 3. We're going to use this form when we plug numbers back in. It's helpful to have that form there. But we also want to be able to see this here because we know that what we have canceled out here is going to be a hole in our graph. So that's my first step, simplifying both the top and the bottom. I'll put a 1 next to it so you know that I finished the first step there. And now when I look at these notes, to do my second step, I have to find and plot. I'll save the plotting till the end. So first we're just going to find the y-intercept, if there is one, by evaluating f of 0. So plugging 0 in for x. Plugging 0 in for x, we're going to plug that into this fully simplified version here. So this is my second step. So I'm going to put a 2. I'm plugging 0 in for x. So just here and here plugging in 0. And I have 0 plus 1 over 0 plus 3. And when we simplify that, we get 1/3. And what that 1/3 is when I plug 0 in for x, I get 1/3 as my y. So that 0, 1/3 is going to be a point on our graph. Eventually we're going to put that down on our graph. And then our third step here is to find the zeros of our numerator, okay, which means we are going to set the numerator equal to 0. So if I set the numerator equal to 0, x plus 1 equals 0, and solve for x, I get x equals negative 1. Sorry, I had that off the camera. X equals negative 1. This is going to be our only x-intercept. Okay. So when we plug negative 1 in for x, we get 0 up on the top, which means that our y value is 0. So negative 1, 0 is going to be a point on our graph. Moving forward to step number 4. Find the zeros of the denominator, if there are any, and state which ones are holes and which ones are asymptotes. Okay. So we can see here, we already have this factored. So these two factors here are going to be what helps us figure out where it equals 0. So this is my fourth step. Okay. So I'm going to take that x plus 3 and set it equal to 0. And then I'm also going to take this x minus 2 and set it equal to 0. Okay. Both of these I'm then going to solve for x. X equals negative 3 and x equals 2. Okay. Here we can see that this x minus 2, this factor here, cancels out. Whenever it cancels out, that's when we are going to have a hole in our graph. Okay. And I don't have those notes with me right now, but when we want to find out our y value of the hole, what I'm going to do is plug this x value into our fully simplified version. So I'm going to take this 2 and plug it back in here for x. So if I were to do that, two plus 1 over 2 plus 3, I get 3/5. So we are going to have a hole at the point 2, 3/5. So on my graph, I'm going to put that as an open circle to show that there is a hole at that point. And then for this other value, x equals negative 3, because it did not cancel out here, we know that that is going to be a vertical asymptote. All right, so now moving on to our next step. find the horizontal asymptotes if there are any. Okay. So following our rules for horizontal asymptotes, okay, we look at the degree of the top and the bottom. It doesn't matter whether you look at it here or over here. You should get the same thing either way. If we look at the degree of the top and the bottom here, they are the same. So we follow the process y equals a over b. If we look at the a and b values, they are both 1. So we have a horizontal asymptote at y equals 1. And then step 6 is going to be plot at least one point in between and beyond each x-intercept and asymptote. So in order to do that, I have to plot these other points first. So I'm going to create my graph here. I'm just making my coordinate plane. And I can create my values on my x and y axis now. -1, -2. So now that I have my coordinate plane done, I'm going to go through each step and see what values it gives me that I should put on my graph. This first step was just simplifying, so that doesn't give me any points. My second step here gives me the point 0, 1/3. So my x value being 0, my y value being 1/3. Doesn't have to be perfect. I'm going to put it at about there. Okay. So that's that point on the graph. My next step is this point here, -1, 0. I can put that on my graph. And then from this next step, we have two things we have to put in. We have to put in this vertical asymptote at -3. So here at -3, I am putting in a vertical asymptote. That means I'm going to put a dotted line in here. Okay. All right. And that tells me that my graph is never going to cross that line. Okay. And then here at 2 3/5, so x being 2, y value being 3/5, which is less than 1, so I'm going to put it at about here. I'm going to put an open circle because that is going to be a hole in the graph. Right. So that is me putting both of these on our graph. And then the last thing we have here is y equals 1. So we are going to have a horizontal asymptote. So I'm going to draw a dotted horizontal line at y equals 1. Okay. And that means that my graph is never going to go through that horizontal line. Okay. So basically what step 6 is here, plotting at least one point in between and beyond, that's finding other points here to help you figure out what's going on your graph. So to the left of this horizontal asymptote, I don't know what's happening over here, so I want to find maybe 1, maybe 2 points to figure out what's going on over here. So maybe I do it when x equals -4 and maybe when x equals -5. So if I actually did that here, all right, this is step 6. All right, if I did f of -4, so that's me plugging -4 in here for x. -4 plus 1 over -4 plus 3. If I do that, I get -3 over -1. -3 divided by -1 is +3. So I have this point here, -4, +3. So I'm going to put that now on my graph, right about here. Okay. So that's a point on my graph. I still can't really tell what's going on to the left here, so maybe I also want to find f of -5. So now if I do f of -5, okay, I'll do that right over here. All right, again, plugging -5 into the fully simplified version. All right, when I plug that in, I get -4 over -2 which equals 2. So I have this point. This is going to give me the point -5. Excuse me. Right, that gives me the point -5, 2. So I'm going to put that on my graph here, -5 and up 2. Okay. So I can kind of tell what's going on here because I know that my graph has to approach this asymptote. Okay. So I know that this is going to come up here and get closer to my asymptote. And it's going to come through this point, and I know it has to get closer to this horizontal asymptote. So it's going to come this way and get close to the asymptote, but never cross that line. Okay. Now over here, I have a couple points, so this is a little better. I can tell that this is going to here. It's going to go to this hole and then approach that horizontal asymptote. Okay. I might want to find another point here down below to figure out where this is coming down. So maybe I'd plug -2 into my function. If I did, I'll do it up here. Okay. If I did f of -2, that again is me plugging -2 into this here. And if I solve that, I get -1 over 1, which is -1. So we have the point -2, -1. So I can put that down here on my graph, -2, -1. And we can see now that this is going to come to this point and approach this asymptote here. All right. We are already 12 minutes into this video, so I'm going to stop it here and then do another video for the second example.